welcome to Math Simplified. This video is for 9th standard students. Please subscribe and share with your friends also. Today we are going to study SURDS. In the previous video we learnt about radical notations and fractional indices. This topic is in continuation of the same. A surd is an irrational root of a rational number. Nth root of A is a surd provided n belongs to natural numbers, n is greater than 1, A is rational. N is the order of the surd. So, what is important to note here is that surd is an irrational number. Okay, it's an irrational root of a rational number. N is called the order of the surd. A we know is a radicand, and n should be always greater than 1. Okay, and A is a rational number and it is called a radicand. Okay, there are some laws of surds. It's the same thing we studied in the last video. Nth root of x raised to m is equal to x raised to m raised to 1 upon n. You multiply the numerator, x raised to m upon n. Nth root of x raised to n is equal to x raised to n raised to 1 upon n. This becomes x. Example, square root of x square is equal to x. Fourth root of x raised to 4 is x. This is very important. Many sums will come on this. Okay, nth root of x multiplied by nth root of y is equal to, convert to fractional indices and then multiply both x and y raised to 1 upon n. So the important thing here to notice is that when the order is same, then we can multiply the radicand like this. But if it is a different order, you cannot multiply. Okay, the same thing goes here. If the order is same, you can divide. So you can write this: nth root of x divided by nth root of y is x divided by y raised to 1 upon n. Okay, or nth root of x upon y. So this is also very important. You should be careful with this. Okay. Exercise 2.6. Question 1. Simplify the following using addition and subtraction properties of surds. Okay. Now here we are going to add some surds, subtract them. These are all problem sums on this. So here the important thing to note is you can add or subtract the same surds with the same order as well as the radicand. See, root 3, square root 3, square root 3, square root 3. It's the same surd. Then only you can add or subtract them. If there is any difference either in the order or in the radicand, you cannot do that. Okay, so the surd should be same. Then only you can add or subtract. So here this is a common factor, root 3. Take it out, put the rest in the bracket, 5 plus 18 minus 2, and you solve this, you get 21 square root 3. So here 4 into third root of 5, 2 into third root or cube root also you can say of 5, 3 into cube root of 5. So here cube root 5, cube root 5, cube root 5. Fine. So then we can go ahead with the addition and subtraction. Take this common factor out, put the rest in a bracket, 4 plus 2 minus 3. Solve this and you will get the answer. Number 3. 3 into square root 75, 5 into square root 48 minus square root of 243. So first let us see this can be factorized. So let us first factorize this. 75 is 5 into 5 into 3. So you can write square root 75 as what? 5 square multiplied by 3. And what is square root of 5 square? That is 5 and square root 3. So this is the simplest form. We have converted square root 75 into 5 root 3. Similarly 48. Take this number, factorize it. You get 2 raised to 4 into 3. So now you want square root of 48. So put it like this. So square root of 2 raised to 4 is 2 raised to 2. Square root 3, keep it as it is. 2 raised to 2 is 4. 4 square root 3. Similarly factorize 243 and you will get this. Again do the square root. You will get 3 raised to 2 multiplied by square root 3. That becomes 9 square root 3. So in this sum, all these values you have simplified. Square root 75, square root 48, square root 243. Put the simplified values. So 3 into square root 75, 5 into root 3 plus 5 into square root 48 is 4 root 3 and minus square root 243 is 9 square root 3. That's all. Now this is in the simplest form. You open the brackets, this becomes like this. Now root 3 is the common factor. You keep it outside the bracket and you can solve the sum. You will get the answer as 26 root 3. Okay, next is 5 into cube root of 40 plus 2 into cube root of 625 minus 3 into cube root of 320. Again the same method. Simplify 40, you will get these factors. Simplify 625, you will get these factors and all. Then do the cube root of all these numbers, you will get and reduce it to the simplest form. You will get these. Okay, now put these values here and solve the equation. Remove the common factor and solve this. You will get this answer. Okay, question 2. Simplify the following using multiplication and division property of surds. So here, so I told you, you can multiply the surd if the order is same. You don't have to worry about the radicands. It can be different. Whereas for addition subtraction, the whole surd should be same. Okay, then only you can add or subtract. For multiplication division, only the order should be same. Okay, here it is. The order is 2. So square root, put the sign, you can multiply all this. 3 into 5 into 2, you get the answer. Similarly here, the order is the same, so you can divide. 35 divided by 7, you get the answer. Here also the order is same, so you can multiply these numbers and do the cube root, or you can, I have simplified each one. What is cube root of 27? 3. Cube root of 8? 2. Cube root of 5? 125 is 5. So you get the answer. Okay, so here this is an identity that x minus y into x plus y is x square minus y square. That formula they have applied. So 7a minus the 7 square root a minus 5 square root b multiplied by 7 square root a plus 5 square root b. So you apply the identity and you do the square, you will get this answer. Or you can open the bracket. You know how to open. 7 into root a multiplied by this whole bracket minus 5 root b multiplied by this whole bracket. Even if you do that, you will get this answer. Next sum. This sum looks very complicated, but actually it's very simple. Okay, so here square root of 225 upon 729. We know square root of 225 is 15 and square root of 729 is 27. Minus, similarly, this becomes 5 and 12. 5 upon 12. Square root of 16 upon 81 is 4 upon 9. Okay, so I have written it down. Now you just have to solve it. First solve this numerator. This portion you have to take, first I am reducing this 15 upon 27 to 5 upon 9 minus 5 upon 12. So this you have to solve by finding the LCM, that is 36. So you can do this is simple sum on fraction. You will get this answer. Question 3. If square root 2 is this, square root 3, they have given the values square root 5, square root 10. Then find the values of the following, correct up to 3 places of decimal. So this is the sum. Square root 40 minus square root 20. We have to find. Okay. So what is square root 40? Square root of 4 into 10. And 20 is 4 into 5. So you square root of 4, 2. Take it out and you're left. This becomes 2 square root 10. This becomes 2 square root 5. Now simply put the values of square root 10 they have given you, square root 5 they have given, and solve it. You will get the answer. The next sum, again here first solve this. This is what? 3 into 100. Square root of 100 is 10. 3 leave it as it is. So 10 root 3. This is what? 9 into 10. So square root of 9 is 3. Leave the square root 10 as it is. This is 4 into 2. Square root of 4 is 2. And leave the 2 inside as it is. Now you have simplified it like this. Now put these values. Square root 3, square root 10 and square root 2 and solve it, you will get this answer. Question 4. Arrange surds in descending order. So these are the given surds. Okay, now look at the order. They are all different orders. We are going to make the order of the surds same. For that, we are going to take the LCM of these orders. Okay, so LCM of 3, 9 and 6 is 18. So first take this 1 upon 3. So this becomes 6 upon 18. 1 upon 9 becomes 2 upon 18. 1 upon 6 becomes 3 upon 18. So take the first surd. So this is 5 raised to 1 upon 3. 1 upon 3 becomes 6 upon 18. Take the 6 inside the bracket, you will get a value like this. Similarly, do for all the 3 surds. Now you check out the values inside the bracket. Order has become same. That is 18th root it has become. Okay. Now we will just look at so 5 raised to 6 is definitely a very high value. So this will come first. Okay. Then 4 raised to 2 is 16. 3 raised to 3 is 27. So this is the next value. Okay. So this is 6th root of 3. Write down next. And this has the least value. So this is the descending order. So here there is another surds. We have to write it in descending order. So here we have to, the actual order of the surd is 6. This is 12 and this is 4. Okay. Now what is the LCM of this? This is 12. So let us convert this, write it like this, and you have to write it in terms of the LCM. Okay. So 1 upon 6 will become 2 upon 12. Okay. Now you take the 2, 5 raised to 2, that becomes 25. 25 raised to 1 upon 12. Similarly, this is already 7 raised to 1 upon 12. We don't need to do anything. It's already in that form. Here, this is 3 raised to 1 upon 4. This becomes 3 raised to 3 upon 12. So 3 raised to 3 is what? 27. 27 raised to 1 upon 12. So all the surds have got the same order. That is the 12th order. Okay. Now look at the values. Which is the highest? This. So this is descending order. You will write this first. Then you are going to write this. And then this surd. Last. Okay. Question 6. Can you get a pure surd when you find the sum of two surds? Yes, we can get a pure surd. For example, sum of two surds. You can take any example. I have just taken this. So 3 root 5 plus 2 root 5 is equal to 5 root 5. Subtraction, difference of two surds. Okay, 3 root 5 minus 2 root 5 is root 5. Multiplication of two surds. Yes, root 3 into root 2 is root 6. Division. Yes, root of 10 divided by root of 2 is root of 5. So so yes for everything. Can you get a quotient of two surds? If you do, can you get a pure surd? Yes. So these are the examples. You can choose any examples. Okay. Can you get a rational number when you compute the sum of two surds? So this is a surd. This is also a surd. If you add these two, I get a rational number. The surd gets cancelled. So here subtraction of surds. Again, I get a rational number. Multiplication, yes, I can get. So yes to all. So we can get a rational number when we do these operations on surds. So here we come to the end of the exercise. Please go through the video once again. Pause the video and practice the sums.